Welcome to Day 4 of the 60-Day Production Engineering Challenge. Yesterday we covered error budgets. Today we are tackling monitoring fundamentals. And I do not mean dashboards. Dashboards are a side effect. Monitoring is the practice of collecting signals from your system so you know when things break and have enough data to figure out why. Let us get into it. Google's SRE team distilled their operational experience into 4 golden signals: latency, traffic, errors, and saturation. Let me break down each one with the nuance that actually matters in production. Latency is how long requests take, but here is the detail most people miss. You need to track latency for successful requests and failed requests separately. Think about it. Your database goes down. Requests that normally take 200 milliseconds to query, process, and return data now fail in 5 milliseconds with a connection refused error. If you lump those together, your average latency goes down. Your dashboard looks like things got faster. Meanwhile, users are getting errors. Separate your success and failure latency. Always. Traffic is the demand on your system. For a web API, that is requests per second. For a streaming service, maybe concurrent connections. For a message queue, messages per second. The unit depends on what your system does. Why does traffic matter beyond capacity planning? Context. If your error rate jumps from 1% to 5%, the severity depends entirely on traffic volume. 5% errors at 10 requests per second affects maybe one user. 5% at 10,000 requests per second means hundreds of people are having a bad time right now. Errors are the fraction of failing requests. The tricky part is defining what counts as a failure. HTTP 500, obvious, 230 to 330. Saturation tells you how close any resource is to its hard limit. CPU, memory, disk, connection pool slots, file descriptors. Saturation is your early warning system. By the time latency spikes because of resource exhaustion, you are already in an incident. A saturation alert on connection pool usage at 85% gives you time to scale up or investigate before connections start getting rejected. Now let me talk about the 2 fundamental approaches to monitoring. Black box and white box. These are not competing approaches. You need both and they serve different purposes. Black box monitoring tests your system from the outside. A health check probe running from an external host that hits your API and checks if it gets a 200 response in under 2 seconds. This is exactly what your users experience. 330 to 430, white box monitoring uses internal instrumentation. Those Prometheus metrics your application exposes showing request counts, latency histograms, queue depths, cache hit rates. White box monitoring sees problems that black box cannot. Your database connection pool is at 95% capacity but requests are still succeeding. Black box says everything is fine. White box is warning you that one more traffic spike will cause an outage. The operational rule is this. Page on black box alerts because they reflect actual user impact. Debug with white box metrics because they expose internal state. A black box alert tells you the house is on fire. White box metrics help you find which room. Let us talk about collection models. Prometheus uses pull-based collection. It scrapes your metrics endpoint on a schedule, typically every 15 or 30 seconds. StatsD and Graphite use push, 430 to 530, pull has a nice property. If Prometheus cannot reach your target, that is itself a signal. The up metric goes to 0 and you know the target is down or unreachable. With push-based systems, silence is ambiguous. Did the service stop pushing because it crashed, or because there is nothing to report? Push works better for short-lived processes. A cron job that runs for 10 seconds might finish between Prometheus scrape intervals and never get its metrics collected. Push-based systems handle this naturally because the process sends its metrics before it exits. Now here is the section that will save you from a real production incident. Label design. Prometheus metrics have labels, which are key-value pairs that let you slice your data. Method equals get, status equals 200, endpoint equals /API/users, 530 to 630, the rule that matters most. Label values must come from a bounded set. HTTP methods, bounded. There are maybe 8 of them. Status code classes, bounded. Endpoint patterns, bounded if you use route templates instead of actual URLs. User IDs, unbounded. And that is where teams get burned. I have seen a team add customer ID as a label on their request duration metric. They had 200,000 customers. That single metric became 200,000 time series. Multiply by the number of label combinations and they had millions of series. Prometheus ate all available memory and crashed during a traffic spike, which was the exact moment they needed monitoring the most. The fix was replacing customer ID with a customer tier label, which had 3 possible values, free, pro, and enterprise, 6:30 to 7 o'clock, to recap. For golden signals, latency, traffic, errors, saturation. Black box for alerting on symptoms, white box for diagnosing causes. Pull-based collection with Prometheus is the standard for most teams. And keep your label cardinality bounded or your monitoring will fail when you need it most. Tomorrow on day 5, we set up Prometheus and configure it to actually scrape targets. See you there.